Here we have an expression with x squared in it, so that means it's a quadratic expression. The minus sign means it's the difference between two terms. Finally, we notice that they're both perfect squares, x squared and 3 squared. So that means we're asked to factorise the difference of two squares. It's good practice to write down what the two terms are that are squared. The first thing here that's squared is x. The second term that's squared is 3, because 3 squared gives me 9. So the two factors here are x plus 3 and x minus 3. The order in which I write these two factors is not important. I could have written x minus 3 on x plus 3. Note this time the factors are expressions. X plus 3 is an expression in two terms. Get into the habit of checking your answer. X by x is x squared, 3 minus 3 is minus 9, and 3 times x is 3x, and x times minus 3 is minus 3x, which means I've no terms with x. Here we have another example. The first term that's squared is x, the second term that's squared is 7. So it's x minus 7 on x plus 7. And again, good practice to check our answer. This time I've got a coefficient of x squared other than 1. So 2 squared is 4. So 2x all squared is 4x squared. This time 5x all squared is 25x squared. And 4 squared is 16. Again, I'm checking my answer. After a while, you'll be able to do this in your head, but at the moment, I'm showing you that I'm doing it. Don't let this one put you off. The first thing that's squared is 5x minus 3, and the second thing that's squared is 2. It's no different to the rest of the sums. Now coming to the end of the sum, I notice the second bracket has got a common factor. It's 5. So I'm going to take out that common factor so that my expression is fully factorised.